Hi, everybody. In this part of the video or the project, we're going to be looking at writing our radical function from our graph paper now. So we're actually going to start here, all right, on our graph paper that we have. And the first thing we need to do, and let's look at the directions, is we need to restrict the domain. So we need to figure out what is the horizontal and vertical distance you want to be modeled by the function. So we're going to pick the two endpoints, point one and point two. All right. By the way, the video that I'm recording is going to go right here. So let's get started. Once we choose our endpoints, we're going to decide which one is going to be the starting point or the center. I want you to know that before you go back and look at it, because you need to be thinking about that as you choose, well, as you place your line and as you choose which point that you're going to use. The other point is going to be a point that passes through the line. That's why you're choosing 2 points. Okay, so let's go to our Jamboard where I have my graph, and let's go ahead and look at the radical function, which is in red. That's our radical function. And I'm going to use blue, so the contrast, the bright blue. So the contrast will be real around here. So this is my radical function. So this is going to be my starting point, and this is going to be the point that it goes through. That's what I've decided. All right, so what's that location? We do it the old fashioned way, right? If you draw to the x-axis and to the y-axis, it'll kind of tell you what they are. So let's go. If this is 0, 0, right? Then this x coordinate is 1. And this one is up here is 1, 2, 3, 4, 5, 6. So that's 6. So my starting point is 1, 6. And I decided to do that based on the look of the graph, like how a radical looks. So if you're not sure, always go back to your parent function document. And when you come near, you'll see the radical function right here. And look at the behavior of it, right? Look at the behavior of it. So that's why I'm going to use this as my starting point, because in the parent function, that is the starting point. So I'm not doing anything different from what would normally happen. And I'm going to use this endpoint over here as my endpoint, the one that it passes through. Okay? So that's how I got that idea. All right, so let's go. And if you can see, visually you see, this looks like this. Just translate it. Okay, so now that I have my first point, let's go ahead and identify the second point. All right, let's use a different color for that. Not orange, but let's use like a hot pink or something. Okay, so this point here, and then here. So this is a 7, right? And then going down here would be 2, 3, 4, and 5. So my second point, my end point, the point that it passes through, is 5, 7. Voila. So what does that mean? That means that this is H and K. So H is 6, excuse me, is 1, and K is 6. Okay. And this is X and Y. So X is 5 and Y is 7. So now that I know that information, I could take this information to my workplace and go ahead and complete the rest of this task. So here I am in my workspace. And as you can see, I got the directions with me here. And so the directions are written as well as you have this video to walk you through. So I am going to take the information I have and fill it in and go step by step and answer these questions. Okay, so my point is 1, 6. And we have decided that that's H and that's K. And my other point is 5 and 7. And we have decided that that's X and Y. Okay, so check, check. Next, write the function, write the radical function. So y is equal to a square root of x minus h plus k. You're going to get used to this form. It literally is used for everything. And let's go ahead and identify what we said the values were. So we said y was 7. We said x was 5. We said h was 1. And we said k was 6. So 7 is equal to a square root of 5 minus 1 plus 6. Now we're ready to solve. Remember, we got to isolate a. That's our job, to isolate a. So let's start with order of operations. 5 minus 1 is 4, right? Got to start with the radical first. All right, plus 6. Square root of 4 is 2. Plus 6. Now, so that's the same thing as saying 2a plus 6, right? Now I got to isolate a, like I said before. We got to get a by itself. So we're going to do the opposite and subtract 6 from both sides. And 1 is equal to 2a. Again, isolating a. This is attached by multiplication. So we need to divide by 2. And when you divide by 2, the 2's cancel out, equal to 1, right? So we end up with a is equal to 1/2. So now we can write our function. So y is equal to 1/2 square root. What is h and k? H was 1 and 6. H is 1, k is 6. So x minus 1 plus 6. That's our function. We're finished. All right, so now let's go on to the next question. It says to find the key features, fill in the table with each of your answers. So here's what you need to know, right? Our domain and our range are going to be restricted. Okay. That's what's similar about the rational and the radical function. They both have restricted domains. So the radical is restricted because you can't take the square root of a negative number. The rational function is restricted because you can't divide by a 0, right? So let's go ahead and look at what our restricted domain is. We're actually going to go back to our picture and look at what the x values are and what the y values are that restricted our horizontal and our vertical distance. So as you can see here, we are back, and look, our domain, and the good thing about it is that if you draw it like this, like how I did, you can see what your domain is, right? My domain went from 1 to 5, right? So I would write that as 1 is less than or equal to x, which is less than or equal to 5. That would be my domain, okay? My restricted domain, because the endpoint is 1 and the other endpoint is 5. Now, let's look at the y coordinates, right? It's also restricted that way as well. So my range, my lowest number for a range is 6, right? And then that goes to 7. And in this case, instead of writing x, we're going to write y. So there goes my restricted domain and range. So now let's go ahead and start filling out our table, because we got enough information to fill out some stuff. So here we go. This is 1/2. This is 1, and this is 6. The function is y equals 1/2 square root of x minus 1 plus 6. The domain is 1 to 5, right? The range is 5 to 7. No, 6 to 7. It's 6 to 7. y. Don't forget to make that a y. All right, your starting point is 1, 6. We chose that, right? So now we got to find our y-intercept, our x-intercepts, and remember roots is another name for x-intercepts, and our end behavior. We're going to save end behavior for last and go ahead and do the x and y intercepts. All right, so now let's go find our x and y intercepts. So to find the y-intercept, remember where the line crosses the y-axis, we are going to let x equal 0. And then to find the x-intercept, we are going to let y equal 0. And you see that's the difference between the two, right? They're similar because one of the coordinates is equal to 0, but they're different because we're going to let x equal 0, and for the other one, we're going to let y equal 0. For the y-intercept, we're going to let x equal 0. For the x-intercept, we're going to let y equal 0. So we have our function. All right, y equals 1/2 square root of x minus 1 plus 6. And we're going to let x equal 0. So, and we're going to build everything around it. So y is equal to 1/2 square root of 0 minus 1 plus 6. All right, we're going to solve this and find out what y is. Y is equal to 1/2 times the square root of -1, because 0 minus 1, we got to do order of operations. 0 minus 1 is -1 plus 6. We can stop right there. This is a flag on the play right here. Okay, so flag, red flag at that. Because we're taking the square root of a negative number. That's the reason why. Taking the square root of a negative number. So we don't need to go any further. We already know there is no y-intercept. That's our conclusion. There is no y-intercept. Okay? So next, let's go find the x-intercepts. So same thing, function, y equals 1/2 square root of x minus 1 plus 6. This time we're going to let y equal 0, right? So y is equal to 0. And then we're going to build everything around it. And we are going to isolate x to solve this. So we start by trying to get the radical by itself because we learned how to solve equations. So we're going to subtract 6 from both sides. Okay, 0 minus 6 is -6, is equal to 1/2 square root of x minus 1, right? I want to get rid of that fraction now so I can get that radical by itself. So that means I'm going to multiply both sides by 2 because 2 is the reciprocal of 1/2. And when I multiply by 2, that's going to actually cancel that out. So 2 times and 2 times over here. And let's build everything else around it. -6 is equal to 2 times 1/2 square root of x minus 1. All right, so this cancels, right? And is equal to 1. So I end up with -12. 2 times 6 is -6 rather. Is -12 is equal to the square root of x minus 1. I can stop right there. That's another flag on the play. That's another flag on the play. We have a radical equal to a negative number. Okay? Radical equal to a negative number. So, can't do that. That's another red flag. So, whenever you have taken the square root of a negative number and solving these for the x or y intercepts, or whenever you have a radical equal to a negative number, there is there's no solution. So because there's no solution, there is no x-intercept. That means this line does not cross the x-axis and it does not cross the y-axis. And that's not too far-fetched because if the parent function is translated up the way this is, So this function was actually translated, it looks like right and up. So that means it definitely wouldn't, look where it is right now. It's only touching the x-axis one place. So if I translate this up and to the right, it's not going to cross the x or y axis. So that makes plenty of sense, right? So now let's go back to our table and write out our information. This is going to be NA, and this is going to be NA. It does not cross the X or Y axis. We'll go back to our picture and we can clearly see it does not cross the X or Y axis. All right, so check. Ooh. So check on the equation, check on the domain, the Y, X and Y intercept. All right, so now we got to do these last two things. We have to describe the end behavior and look at the verb and look at the write the verbal description of the transformation. Okay. So let's do end behavior real quick, and then let's do. So remember with end behavior, we have the left side and we have the right side. Okay. So the way we say left side is as x approaches negative infinity. The way we say right side is as x approaches positive infinity. So now let's go look at the graph so that we can actually determine what's happening there. All right, now, so on the left side of this function, right here, where this point is, on the left side, as x approaches negative infinity, it really just stops right there, right? It don't go any further, right? So what does y approach? So 6, and it stops. It doesn't go anywhere else. Just 6. It doesn't go any lower. So y goes to 6. That's what happens, right? So you go back to your workspace. So y approaches 6 because it doesn't go any lower. Okay. Now let's look at on the right hand side as x approaches positive infinity, what's happening? So as x approaches positive infinity, which is on this side right here, what is the y coordinate doing? It stops at 7. That's what it was doing. It's stopping at 7. Now, if the domain wasn't restricted, it would go on forever and ever and ever to infinity. Okay. So I can say, because this is my starting point, I can say that the end behavior goes off to infinity, to positive infinity in particular. Okay. So, and we're done with that, right? Now, let me go ahead and be super clear about this. With your radical function on the left, well, if it's, if A is positive, right? If A is positive, um, it is going to, this is right here is going to be the Y value of the starting point. Okay. So when A is negative, it's a little different. We could talk about that. And if that happens with you, but when A is positive, there's going to be the Y value of the starting point. Okay. All right. So we are ready to now do the verbal transformation conversation. That rhymes. Verbal translation conversation. All right, so our function is y equals 1/2 square root of x minus 1 plus 6. So we got to talk about what's happening on each part. Okay, so first of all, this is vertically compressed. All right, because a is between 0 and 1. Right, when a is between 0 and 1, it is vertically compressed. Okay, this has been shifted to the right. This is the horizontal shift to the right. All right. And then this is a vertical shift up. So to the right 1 unit and up 6 units. Now, the other part of this is comparing it to what happened in unit 1. So a vertical compression is a dilation. So this is a dilation by a factor of 1/2. Okay. All right. And these two are translations. Okay. These two are translations. And if I were to write a function notation for it, it'll be T16, like that. It's a translation. So now we have answered all the questions. Let's go ahead and finish filling out our table. So we come back to our table and we fill in the rest of the information here. Okay. So I filled in the end behavior. That was the only thing that we have left. Now, how do you finalize this and go ahead? So first of all, you did all this work right here. Go ahead and hit submit. Okay. So that you are turning in as you go. All right, hit submit. And this is a way for me to be able to check in with you. So if you want me to check in your work, I can do that. Okay. Here, you're going to take a picture of your work, okay, that you did to answer this question. And you are actually going to insert it into the doc. What doc you say? This one. You're going to insert your work. Okay, let's scroll down. And you're going to submit your how you found A right here. That part is going to be submitted there in this place, right? How you found A is going to be submitted here, right? And how you found the key features is going to be submitted right there. Okay. And that's it. And then you, like I said, hit submit again in the upper right hand corner, hit submit so that you turn in your documents. All right. Thank you for your time.